Our universe is vast and full of wonders. We look up at the night sky and see countless stars. Each star is a sun, perhaps with its own planets. These are the things we can see, the familiar parts of our cosmos. They are made of atoms, the same building blocks that make up you and me. Everything we know, from the smallest insect to the largest galaxy, is made of this ordinary matter. It shines, it reflects light, and it interacts with the world in ways we understand. We have built our science around studying this visible, tangible reality. It is the universe we have known for all of human history. But what if this visible universe is only a tiny fraction of what is actually out there? Imagine everything you can see is just the tip of a colossal iceberg. Scientists now believe this is true. There is something else out there, something enormous and mysterious. It fills the space between the stars and surrounds entire galaxies. We cannot see it with our telescopes. It does not shine or cast a shadow. It is completely invisible to us, yet its presence is felt everywhere. We call this mysterious substance dark matter. The evidence for dark matter is overwhelming, even though we can't see it directly. We see its effects on the things we can see. Galaxies spin much faster than they should. If they only contained the stars and gas we observe, they would fly apart. Something unseen is holding them together with its powerful gravity. It is the hidden scaffold upon which the entire universe is built. For centuries we have asked the question, are we alone in the universe? We have searched for life on other planets, like Mars. We have listened for signals from distant star systems. Our search has always focused on life as we know it. Life made from carbon, water, and the familiar chemistry of ordinary matter. We look for planets in the Goldilocks zone, where conditions are just right for liquid water to exist. This is a natural starting point. We are looking for something that resembles ourselves, because it's the only kind of life we have ever known. But the existence of dark matter invites a much bigger, more mind-bending question. What if life doesn't have to be like us at all? What if life could form from entirely different ingredients? If the universe is mostly made of this strange, invisible substance, could it have its own form of life? Our search for dark matter has so far focused on finding one single, lonely particle. We tend to imagine it as a ghost, drifting silently through the cosmos, interacting only through gravity. But what if this view is just too narrow? What if dark matter is not simple at all? Think about our own universe. It is not made of just one particle. It is a bustling zoo of different particles like electrons, quarks, and photons. These particles interact with each other through a variety of forces, creating the beautifully complex world we see around us. So perhaps the dark matter realm is just as rich and varied. This idea is known as complex dark matter. It proposes that the hidden 85% of the universe is not just one thing, but a whole family of different dark particles. Just as we have an electric force that governs our atoms, maybe there is a dark force that only affects dark matter particles. This force would be completely invisible to us, but in the dark realm it could be just as powerful as our own electromagnetism. It could bind dark particles together, creating new and stable structures. This completely changes the picture. Dark matter would no longer be a passive, silent ghost. It would be an active, dynamic component of the universe. If a dark force exists, it opens up a universe of possibilities. Suddenly, dark matter has the potential for its own chemistry, its own physics, and its own unique set of rules. If a dark chemistry exists, could it assemble into life? This is the ultimate leap of imagination, but it is one grounded in logic. On Earth, life began when simple molecules organized themselves into more complex structures that could replicate. Over billions of years, this process of natural selection led to the incredible diversity of life we see today. If the dark sector has its own complex molecules and a source of energy, a similar process could unfold there. Dark life would begin as simple, self-replicating dark molecules. These would be the dark equivalent of DNA or RNA, carrying a blueprint for their own existence. Over cosmic timescales, these simple dark replicators could evolve. Natural selection would favor those that were more stable and better at copying themselves. They might develop ways to protect themselves from their environment, perhaps by forming a dark membrane around themselves, creating the first dark cells. These simple dark organisms would slowly grow more complex. They might learn to harness the energy from dark matter annihilation more efficiently. They could develop new ways to move, to sense their environment, and to interact with each other. A hidden, dark evolution could be taking place right under our noses. What would these beings look like? It is impossible to say for sure. They would be perfectly adapted to a world without light and with very different physical laws. They would not have eyes, as there is no light for them to see. Instead, they might sense the universe through gravity or the weak force. Their bodies would not be made of flesh and blood, but of exotic dark matter substances. They might be more like clouds of organized energy than solid objects. Perhaps they would be enormous, diffuse beings, as large as a solar system, living in the vast, empty spaces between stars. The most mind-bending part of this idea is where this life would be. It would not be on a distant planet in another galaxy. It would be right here, all around us. The Earth is moving through the Milky Way's vast dark matter halo right now. This means that at any given moment, a stream of dark matter particles is passing through the room you are in, through your body, and through the planet itself. If some of that dark matter is organized into life, then that life is passing through you too. It is a staggering thought. A hidden biosphere could be interpenetrating our own, completely unseen and unfelt. These life forms would be utterly oblivious to us, just as we are to them. Our world of light and matter would be as transparent and irrelevant to them as their dark world is to us. They would not see our sun, our cities, or our forests. Our strongest radio signals would pass through them without a whisper. When we walk through a field, we are careful not to step on the flowers. A dark being might pass through the entire Earth without even noticing it was there. Our two worlds would be like two different radio stations broadcasting at the same time on different frequencies. We are tuned to the frequency of ordinary matter, while they are tuned to the frequency of dark matter. This essay will explore this incredible idea. We will journey into the heart of the hidden universe and ask one of the most profound questions of all. What if life exists in dark matter? Detecting life made of dark matter presents one of the greatest scientific challenges imaginable. We cannot simply point a telescope and take a picture, since this life would be entirely invisible to light. We also can't send a probe to collect a sample, because it would just pass right through it. Our usual methods of searching for life are honestly completely useless here. So we have to think differently, using the one connection we know we share with the dark sector, the force of gravity. Everything with mass creates gravity, and a complex dark life form, especially a large one, would be no exception. It would have a gravitational signature, a subtle fingerprint on the fabric of space-time. So our first approach is not to look, but to listen for this gravitational whisper. We're actually already getting pretty good at this. Instruments like LIGO and Virgo can detect gravitational waves, which are ripples in space-time caused by massive cosmic events, like black holes merging. In the future, even more sensitive detectors could be built. These instruments might be able to pick up the faint gravitational disturbances caused by a very large, dense dark matter object moving through space. If we detected a gravitational signal that didn't match any known astrophysical object, like a star or a black hole, it could be our first clue that we've found something extraordinary, something organized and complex. Another way to use gravity is through gravitational lensing. This is a phenomenon where the gravity of a massive object bends the light from stars and galaxies behind it. We already use this technique to map the distribution of dark matter halos around galaxies. Let us assume, just for a moment, that we have found a credible sign of dark life. We have detected a gravitational signal or an energy anomaly that points to a complex, non-random object. The next question is almost overwhelming. Could we ever communicate with it? This would be a challenge far greater than contacting any hypothetical alien civilization made of normal matter. We do not share a language, a biology, or even a basic physics. Our primary means of communication, electromagnetic waves like radio signals, would be completely useless. Sending a message to a dark being would be like shouting into a soundproof room. To even attempt communication, we would need to find a shared language. The most likely candidate is the language of mathematics and physics itself. Gravity is universal, so perhaps we could send a message using gravitational waves. This would be an engineering feat on a colossal scale. We would need to create a powerful gravitational wave transmitter, maybe by moving unimaginably massive objects in a controlled pattern. We could then send out a simple, undeniably artificial signal, like a sequence of prime numbers, encoded into ripples of space-time. It would be the ultimate long-distance call, a message written in the very fabric of reality. What if we received a signal first? A highly advanced dark civilization might have already mastered this kind of communication. They might be broadcasting their existence into the cosmos, using modulated gravity. If we ever detected a gravitational wave signal that was clearly not natural, a signal with repeating patterns, complexity, and information content, it would be the single greatest discovery in human history. It would be proof not only of dark life, but of intelligent dark life. Another major challenge is that we are trying to solve this puzzle from a position of deep ignorance. Our current understanding of physics, the Standard Model, is incredibly successful. It describes the world of ordinary matter with stunning precision. However, it has nothing to say about dark matter. It does not predict the particles it is made of, or the forces that might govern it. When we imagine dark life, we are building ideas on top of a complete mystery. It is like trying to guess the plot of a book when we do not even know the language it is written in. We are speculating about the house without having ever seen the bricks. This means our search is biased by our own experience. When we imagine dark chemistry, we base it on our own carbon chemistry. When we imagine dark evolution, we base it on Darwin's theory. But what if the rules of the dark sector are so alien that they do not resemble our own in any way? Given these immense challenges, one might ask, why even bother thinking about it? If it is so difficult, perhaps even impossible to prove, why should we spend our time imagining such things? The answer is simple. Imagination is the fuel of scientific discovery. Every great leap forward in our understanding of the universe began with a moment of wonder, with someone daring to ask a question that seemed absurd at the time. The idea that the Earth goes around the sun, or that matter is made of tiny atoms, were once radical acts of imagination before they became established facts. We must dream of new possibilities before we can search for them. Thinking about dark life forces us to be more creative and open-minded in our search. By entertaining the possibility of a complex dark sector, scientists are already designing new kinds of experiments. They are looking for signals in new ways and considering a wider range of dark matter candidates. We began this journey with a simple question. What if life exists in dark matter? We have traveled from the familiar world of stars and galaxies into a hidden, parallel cosmos. We have explored the possibility of dark atoms, dark chemistry, and a form of life that evolves in the cold, stable darkness between the stars. The idea is staggering, pushing the limits of our science and our imagination. It suggests that the universe we perceive through our senses, the world of light and ordinary matter, is only one layer of a much deeper, more complex reality. We may be living on a single brightly lit page of an immense cosmic book, with the rest of the story written in an ink we cannot see. This exploration forces us to adopt a new and profound sense of humility. For centuries, we have placed ourselves at the center of the story, but we now know that our planet, our star, and even our entire galaxy are not special. The quest to understand dark matter and the potential for life within it is far from over. It is a journey that has only just begun. Scientists around the world are continuing their patient search. In deep underground laboratories, they build ever more sensitive detectors, hoping to catch the first definitive whisper from a dark matter particle. With powerful telescopes, they map the gravitational effects of this invisible substance, looking for any anomaly that might betray the presence of complex structures. Each new experiment and each new observation brings us one small step closer to peeling back the veil of this cosmic mystery and revealing the true nature of our universe. This endeavor is a testament to the power of human curiosity. It is a drive that compels us to ask big questions, even when the answers seem impossibly out of reach. We are explorers by nature. For millennia, we have mapped our world, sailed uncharted oceans, and looked to the heavens in wonder. The search for dark matter is the next great voyage of discovery. It is a journey into an unseen continent that surrounds us all. We do not know what we will find there. It may be a simple new particle, or it may be a new physics, a new chemistry, and perhaps a new form of life. The only way to find out is to keep looking. The ideas we have explored in this essay are on the cutting edge of scientific thought. So the next time you look up at the night sky, remember what you cannot see. Remember the vast, invisible ocean of dark matter through which our Earth is sailing. Remember the hidden universe that surrounds the shining stars. It is a realm of profound mystery and infinite possibility. It is a reminder that we live in a cosmos that is still largely unknown, with its greatest secrets yet to be revealed. The search for answers continues, fueled by our unyielding sense of wonder and our hope that one day we will understand what truly lies within the dark. The journey is the destination, and it is a magnificent one.